Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck. Today we're going to be solving absolute value equations. That's right, we're going to have an absolute value and an x in the middle of it somewhere, and we're going to figure out how to solve those. Let's get started. Before we get started in solving equations with absolute value, we need to know what actually absolute value is. So absolute value, if you ever see a problem like this, where you have these two vertical lines on either side of something, that's called the absolute value. What absolute value does is absolute value finds the distance something is from zero. So if I want to figure out the absolute value of -4, I look at the number line and I say, okay, how far is this number from zero? And I measure it and I see that it's 4 units from zero. Now, what we talk about with distance is you can't really have a negative distance. If I drive 4 miles to work from my house and then I drive 4 miles back, I haven't really gone -4 miles when I went home. I just went 4 miles in a different direction, but we always think about distance as being positive. So the distance from zero is always going to be positive. So the absolute value of 4 is just 4, okay? Now, the cool thing about distance is it's always positive. So if I have a positive 4 in here, the distance from 0 from positive 4 is still 4. It actually doesn't matter. Both of them are going to be a positive number. So when you look at an absolute value, essentially it takes whatever's on the inside and makes it positive, because we're talking about how far that is from zero. Let's see what this looks like if I have a variable inside. We see here we've got an x inside the absolute value. The question is, how do we solve for x when it's inside those absolute value bars? Now here we've got x equals 6, or the absolute value of x equals 6. Now this is going to seem a little strange to you guys, but there's actually 2 answers to this problem. You're used to solving this if you watch my other videos, or almost all of them, there's only 1 answer for x. But here we're going to have 2. And let me show you. Remember, we have the distance from 0. So I could have the distance from 0 for this problem could be 6. So that means that x could have been 6 to begin with. Right? Because x is this distance. But here's the thing. It could be a different one as well. I could have the number be -6. And that x would be the same number. Both of these give me an absolute value of 6. Both possibilities work. So in this problem, what I've actually got is I've got an x that gives me 2 different answers. X could be 6, or x could be -6. Now that's kind of a weird idea, but if you think about it, we could plug both of these numbers in for x and it works. I could throw 6 in here, absolute value of 6, 6, it works. I could put -6 in here, and the absolute value of -6 is still 6. Both possibilities work. So when you're doing an absolute value, most of the time you're going to have 2 answers. There are cases where that's not true, but most of the time you're going to have 2 answers. So keep that in mind as we go through this video. All right, let's look at another problem here. I've got 4 plus the absolute value of x equals 7. Now here what we want to do is we want to try to figure out what x is. Now you're probably able to figure out what x is in this problem. You might even be able to do it in your head. You might say, well, I think x has got to be 3. Because I know that if x is 3, the absolute value of 3 is 3, so 4 plus 3 is 7. You might even have figured out that there's 2 answers, and this is a -3 here. So I could have a positive 3, which spits out a 3, or a -3, it spits out a 3. Either way, you get 7. Both situations work. I want to start teaching you, though, how to think about this in terms of algebra. Because if you are depending on your if you're depending on your guessing ability to be able to solve these, you're probably going to start getting them wrong really quickly. So what I want you to think about instead of doing this in your head is to think about it as algebra. I could change this problem pretty easily and make it look like all these other kinds that we've done. If I got rid of the absolute value and you wanted to solve for x, you'd be like, oh yeah, I remember all those videos you did, Calbeck. You always have to do the opposite, and you should. We want to do the opposite of adding 4, which is subtracting 4, and you get x equals 3. It turns out you can do that even with an absolute value. You can treat the whole absolute value like a variable. Sometimes I like to put a little cage around it so it looks like one thing. So I have 4 plus something equals 7. I can still subtract 4 from both sides. What you're left with then is x equals 3. And remember, there's 2 possible answers. X could have been positive 3 to begin with, or negative 3. There was 2 possible answers. X could be 3, or x could be negative 3. And you think of both answers. When you're writing your answers down for your teacher, make sure you include them both. But I promise this gets harder, because otherwise you just do it in your head. And this one's a little bit more challenging. Again, you could try to do this one in your head, but you might have a little bit more difficulty with it. You probably, if you thought about it, would be able to figure out one of the 2 answers easily. See if you can figure that out right now. You can press pause and see if you can do it in your head. If you figure it out, both answers, I'll be impressed. One of them is 3. Because 3 plus 5 equals the absolute value of 8. But remember, this also could have been negative 8 inside here. So if I have x equals negative 11, that actually, equals negative 13, that also works. Because negative 13 plus 5 gives you negative 8, the absolute value of negative 8 is equal to 8. So there's 2 answers, 3 and negative 13. I want to show you how to get this, again, without using your guess and check method. So if I want to solve this, I need to think about what the absolute value does. I've always taught you in my videos, when you're solving for x, to do the opposite. So you have to think about what absolute value does. What absolute value does is it takes 2 answers, for example, positive 8 and negative 8, and it turns them into one answer, 8. It takes 2 possibilities and turns them into 1. So that means if we want to do the opposite of absolute value, we need to take 1 possibility and turn it back into 2. Because again, I don't know if this was positive or negative to begin with. So let's see what happens. I want to rewrite this. I'm going to say, well, it could have been x plus 5 was positive 8 all along, if x is 3. Or it could have been x plus 5 equaled negative 8, because x was negative 13. You don't know. So you have to write down both possibilities. And if you solve both possibilities, you'll get the answer that we figured out in our head to begin with. You could subtract 5 on this problem, and you get x equals 3. If you subtract 5 from negative 8, you get x equals negative 13. You get 2 answers. Your teachers are going to want to see this work. So even if you can do it in your head, please show them this, or you're probably not going to get full credit, or maybe be accused of cheating in worst case scenario. But when you are solving an absolute value problem, the last thing that you need to do every time is break it up into 2 equations. All right, we're getting harder still. Let's look at this one. You can see here that there's a 2 on the outside. And I'm hoping that you remember, whenever you don't see a symbol, it means multiplication. So this means 2 times the absolute value. A couple of rules about absolute value. You cannot distribute into an absolute value. Okay, so don't ever distribute into an absolute value problem. You need to treat this like it's one big variable. Okay, sometimes I tell my students to think about it, to rewrite it as a variable. You can't touch anything in the absolute value. You can't move it in, you can't take it out. It's a locked box. So please don't go in and out of the absolute value or you'll get a lot of these answers wrong. But if I wanted to solve this problem, this is a lot easier. It's 2 times W, so I would divide. I would do the opposite of multiplying by 2. Again, when I multiply, it makes a big 1. So I'm left with W here equals 10. Here's the thing, though. We're not using W this time. This time, we are using the absolute value. So I want to do the same thing, though. Instead of dividing W by 2, I want to divide this whole side by 2. You can do the same thing. Since the 2 is multiplying times the whole absolute value, you can divide the whole side by the 2 as well, and you end up with then the absolute value of x minus 4 equals 10. And at this point, this looks just like the last problem that we did. We have an absolute value equals a number. Now remember, the whole thing could have been positive or negative. We don't know. So I want you to break it up into 2. Remember, that's what absolute value does. It takes 2 things and makes it one positive possibility. So we're going to do the opposite and break it up into 2 things. We're going to say x minus 4 could have been positive 10. Or x minus 4 could have been negative 10. We don't know. A quick note here. Notice some students want to make this positive, but notice here, nothing inside the absolute value changed. It's the same in all 3 places. The only thing that changed was what the absolute value equaled. So make sure that you're careful about that and you don't switch that. The only thing you're switching is what it equals. So it's positive 10 or negative 10. So I add 4 to both sides here and I get x could have been 14 or x could have been negative 6. Those are my 2 possibilities. All right, let me show you a couple of weird cases here. All right, this is a very common thing that teachers will give you and it's mean. There's a trick on this one. If you don't see it, you'll get the problem wrong. It's another case of our Ninja 1s that we looked at in our crash course on solving. Ninja 1s show up everywhere. Anytime you don't have a number in front of something, there's actually a 1 there. And the same is true here. This is 3 minus the absolute value. That's a negative 1 right there. If you ever see an absolute value with just a minus sign in front of it, please put that negative 1 in to remind yourself that there is a 1 there. Okay, ninjas are super dangerous. If you don't see them, they will stab you in the back or throw a ninja star at you or something. So be really careful about that. So I can solve this the same way I did before. I can subtract 3, again, doing the opposite, treating this like a big variable. That leaves me with negative 1 times the absolute value of x plus 5 equals negative 1. Now I can solve this because I remembered there's a 1 here. I can divide the entire thing by negative 1, which cancels out here. Divide this side by negative 1, and I get x plus 5 equals a positive 1. And now I'm back to where I've started in all the other problems. I have an absolute value equals a number. That means I switch it into 2 parts. It could have been positive or negative. I don't know. I need to consider both cases. So it could have been x plus 5 equals 1, or x plus 5 equals negative 1. You're not sure. Solve both of them. Subtract 5 from both sides here to get x equals negative 4. Subtract 5 over here and you get x equals negative 6. Those are your 2 answers. So be careful, look out for those negative 1s. They show up all the time. All right, here's another weird case for you. A couple of common errors that I see. The first error that I see is students will combine these. But you can't do that because this is 2 times a number. So remember, we can treat that absolute value like a big variable. So if I were to write this, 5 minus 2w equals 11, you would know right away that you can't combine the 5 and the 2. And you can't combine them here. Instead, we need to subtract the 5, get everything out of there first, and then we can solve for our absolute value. So that gives me negative 2 times 2x plus 4 equals 6. Now again, remember I've got a negative 2 out front. That means multiplication. So since it's being multiplied, I need to divide. I'm going to divide both sides by negative 2. And I get the absolute value of 2x plus 4 equals negative 3. Because 6 divided by negative 2 gives you negative 3. Now, a lot of students will just keep working here and not think about it. But there's a problem at this point. I have an absolute value and it equals a negative. Something inside an absolute value gave me a negative number. But that's not possible. I told you before, absolute value always gives you a positive number because you're talking about the distance from 0. So you actually don't have to do any more math if you see this show up on a problem. Anything in an absolute value equaling a negative number, that's not possible. So the answer here is just no solution. No matter how hard you try, there's no value for x that's going to make that true, because no matter what happens in here, it's going to give you a positive number. So this one is no solution. So those are some weird examples. Hopefully that helps you. Good luck with absolute value. They can be a little tricky, but if you remember these few steps, treat it like it's a variable, and when you get it by itself, you need to split it up into 2 equations, or sometimes you get no solution. I'm Mr. Calbeck. Thanks for joining us in Calbeckistan. See you next time.